All right, I'd like for you to solve sine squared theta minus what was that? Hold on. I'm going to see how you do with this. I want y'all to work together on that. It's a little different than what I've done, but I already heard someone say something about factoring, so. I want to give you some time to work this. Give me the general solutions, all right? I want the general solutions to this.
As soon as I was writing it back out, I was like,
I'm going to go get a drink real quick. No.
So easy.
We think we got it.
That so far okay? All right. Well, if two things multiply to be 0, then you can set them each equal to 0, right? I mean, that's what you would do if you were given like a quadratic or something like that, and you factor out an x. You'd set each of these equal to 0, right? So why don't I set each of these equal to 0? That would be right? Okay, what about this? What is this telling you you need to do? Where's the y coordinate? 0. 0 and pi. So what's the general solution for this? 0 plus pi n? 0 plus pi n, or just pi n? That takes care of that. The other one's the one that's more interesting. Any ideas there? Add the cosine to both sides? Okay, and then what? That means where's your y coordinate equal to your x coordinate? The only place that the y and the x are the same, exactly the same, are what? Here and here, right? That's where your x and y are identical. And they're directly across from one another. So that means theta would have to be, let's start out here. I heard pi over 4 plus pi n will get you across to the other one. That's it. That okay? Anybody try and do that a different way? Any questions on this part right here, like why this is this? Y coordinate has to equal the x coordinate. That happens here and here. Just out of curiosity, what would have happened had I changed this to a plus? That would be a plus. That would be a plus. And when you move the cosine over, it would be a negative, wouldn't it? And that means that your y coordinate is equal to the opposite of the x coordinate, which means they're the same values, but they're different in sign. They're different in plus or minus. So if this one's plus, this one's minus. If this one's minus, this one's plus, which means we're talking about those two angles instead. Does that make sense? So this would actually be, instead of pi over 4 plus pi n, you would start out at 3 pi over 4 plus pi n. So a subtle little difference in one little difference here makes a pretty big difference down here. I'll show you a different way you could do this, just so you can see it. When we had this, when we had sine theta equals, or let's go to this one, sine theta minus cosine theta is 0, right? Not the red one, but the original one. And we did sine theta equals cosine theta. You could have at this point divided both sides by cosine. Divided, not subtracted. And then what's the left side? Tangent theta, and then what's the right side? 1. And so you're saying, where is tangent 1? And tangent is 1 here and here. And if you would have done it with the red, then this would have been negative 1. And tangent is negative 1 here and here. Okay. try this one. I think I might do like one or two more examples, and then I'm going to at least start talking about the next section. How about 2 sine squared theta equals 3 parentheses 1 minus cosine of negative theta. There we go. That looks pretty messy, right? Let me remind you of something real quick. Remember that cosine of negative theta is the same as cosine of positive theta. And that was called the even property. Do you remember me talking about that? It's been a while. No? A little bit. And then sine of negative theta is equal to negative sine of theta. This is called the odd property. These are on your formula sheets. The even and odd properties of cosine and sine. So if you ever see a negative angle inside of a cosine, you can just scrap the negative and just turn it into a positive. And that's, what's that? Just on cosine. On sine, if you have a negative inside, you can make it a positive, but then you have to change, put a negative out front. So in this particular problem, we have sine squared of positive theta, right? And over here we have cosine of negative theta, but I can just change that to cosine theta. There's nothing wrong with me doing that, right? Okay, so let me start with that. Let me also distribute that 3 through. So I did 2 things at one time there. I changed this over to cosine theta, and I passed the 3 through. Any suggestions here on how to proceed? You could divide by 2. I guess what you're trying to do is you're trying to isolate this?
Yeah.
The only problem with isolating this right now is that you actually have a cosine theta over here still. So tell me if this seems like a legitimate move to you, and whether or not it makes sense for me to do this. What would be the value of me doing that right there? We would get all cosines instead of sines. So what did I do to go from here to here? The Pythagorean identity. I need to remember that sine squared theta is equal to 1 minus cosine squared theta. So now at this point, I have cosines in everywhere. Let's pass the 2 through. 2 minus 2 cosine squared theta equals 3 minus 3 cosine theta. And this looks like a quadratic in cosine. Guess what I'm trying to get you to see is this. If I had written on the board 2 minus 2u squared equals 3 minus 3u, you would tell me that this is a quadratic equation, right? And the way you would solve it is you would try and set it equal to 0. That's what I have here. I have a quadratic in cosine. So I'm going to get everything to one side of the equation. Doesn't matter which side. I'm going to move everything to the right, though. Only because I don't like the negative 2 in front of, or the negative in front of the cosine squared. So I'm going to move it to the right. So I'm basically going to have 0 on the left side. I'm going to have 2 cosine squared theta on the right, minus 3 cosine theta, and then plus 1. Let's see. Do you all agree with that? I moved this one to the right, which made it positive. I subtracted 2 from both sides, and then this guy was still there. Does that look like a quadratic to you? Zero equals. Now I need to see if this will factor. Does that factor? Again, if I gave you this right here, could you factor that? Could you break that up into two things? Like 2u, u, 1, 1. Can you make this work? Minus minus? 2u squared minus 2u minus u, that would give you minus 3u plus 1. This works. What I'm trying to get you to see here is that that's a quadratic. It's a quadratic with a trig function instead of just a letter like u or x.
I mean, we could still use substitution in that.
You could use substitution here, yes. So here you should get 2 cosine theta minus 1 minus 1. Y'all follow? Now what? Set each of those equal to 0. Right? Set that to 0, set that to 0. I mean, that's what you would have done over here, right? If this was equal 0, you would have set each factor to 0. That's what we're going to do. So we're going to have 2 cosine theta minus 1 equals 0. That's one equation I have to solve. The other one is cosine theta minus 1 equals 0. On that first equation, this looks like the little linear one that we had earlier. We're just going to isolate cosine theta. So add 1, divide by 2. Cosine theta is a half, and cosine theta is 1. And now you just, cosine is the x-coordinate. Where's the x-coordinate? A half. We actually did that earlier, didn't we? And then this one is saying, where is the x-coordinate 1, which only happens there? Pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n. Again, this is a problem we did earlier. Okay, and then this one, well, it's just this and then come all the way back around. So start at 0, add a full revolution, 2 pi n. So you could just say 2 pi n. All right. This is 8.3. I think I'm going to end it there. All right. Make sure end this section there, not end the class there. Yes.
Well, since you're going to end it here, I was going to ask, is there going to be chances where we're going to have a problem like this with restrictions? And with restrictions, we'd have to figure all of it out, right?
Potentially in the homework, but on a test, no. On a test, I want general solutions because they're faster. And theoretically, if you have the general solution, you have everything. The intervals just make you plug in, and it just takes time. Okay. Yeah, I think I'm going to end it there. Yep. All right, so we will move on to 8.5 now, because we already did 8.4. 8.4 was the identities. You loved that. You loved it. Loved it. So what we're going to do now is we're going to add some more formulas to our list of formulas. And these are on your formula sheet. The next few sections, we're really going to start to throw more formulas into our bag. All right, we're going to have this section is sum and difference formulas. Then we're going to have, after that, double and half angle formulas, and just more and more formulas. Product and sum, product to sum formulas. A bunch of things are coming down the next three sections. But these sum and difference formulas, they're actually used quite a bit. So let's take a look at them. 8.5, the sum and difference formulas. I want to make sure I use the same notation. They use alpha and beta in the book. Okay. Alpha plus beta equals. Now don't put this question mark, but that's just me thinking out loud here. All right, so what if we take sine, question? Yes?
Are these formulas going to be on the sheet, or we have to memorize?
They're on the sheet, right? They are on there, yes. I wouldn't say you have to memorize them. If it's something that should be memorized, I'll tell you. And it's not, and I'm not saying it should be memorized because you need to memorize. It's that you don't want to be like in calculus and be like that student, like having to look up this thing. You know what I'm saying? Like you want to have certain, like Pythagorean identity, sine squared theta plus cosine squared theta equals 1. That has to be hardwired. I'll let you know if there's anything else that needs to be hardwired. This one, if you can hardwire it, great. If not, know where it is on your formula sheet. So this says, look, let's say we want to figure out what sine of alpha plus beta is. Now let's try and understand what this means. If we have a circle, and let's say somebody gives me an angle here, alpha, okay? Then sine of alpha is that distance, isn't it? Agreed? Because that's the y-coordinate. That's that distance. Now somebody gives me a different angle, beta. So beta goes from here to here. Right? Then this is sine of beta. Agreed? The y-coordinate? Yes? No? Yes? No? Maybe so. Okay. But what about sine of alpha plus beta? So if this is alpha, right? That's alpha. And beta is like that big, right? Then when I add the two angles together, I get an angle that's somewhere over here, right? So let me draw that one. Alpha, let me take beta and I'm going to add alpha. So I don't know. Looks like this angle right here would be alpha plus beta, right? Agreed? If this is 10 degrees and that's 20 degrees, then alpha plus beta would be 30 degrees. This right here is sine of alpha plus beta. Do you see the difference between sine alpha, sine beta, and sine of alpha plus beta? So the question is there a way that we can get the answer to this using these two. Does it look like this height is just these two heights added together? Like if I take this height and add this height, am I up here? Yes? So if I take this right here and I stack on top of it that, I'm up here, right? Is that this height? No. It doesn't look like it, right? It doesn't look like it is. In other words, this is what I'm saying. This does not appear to be sine of alpha plus sine of beta, does it? It does not appear that all you do, if you add the angles together, you just don't add the y coordinates together to get the new y coordinate. That does not work. Do you all agree with the picture? It doesn't really seem like it works that way? So the question is, what is the relationship? Is there a relationship between these and those? Well, there is. It's rather complicated, though. Here's what it actually turns out to be. It is sine alpha times cosine beta plus sine beta times cosine alpha. So unfortunately, it's a lot more complicated than just adding the two together. See, a lot of students, they see something like this and they say, oh, here's what I'm going to do. I'm just going to distribute sine through. And it doesn't work that way because sine is not a number. This is a function. You're taking sine of these two things added. And that, unfortunately, turns out to be this. They call this a sum formula because what it allows you to do is take the sum of two angles, right? The sum of two angles, take the sine of it, and somehow get the answer by just evaluating the sine and cosine function at the individual angles. I'm going to give you an example right now, but that's the formula. A way you might be able to remember this, I mean, it's like they trade places. You do sine of alpha, cosine beta. Then you say plus, then you switch it, sine of beta, cosine alpha. Right? You're just going to have to take that on faith. I can prove that. If you want to come to my office, we'll do the actual, there's a lot of geometry that you can do to prove that this is true. It's actually pretty cool. But it just takes up probably about 30 minutes to do it. All right, how about this? What if I were to have switched this, instead of this being plus, what if I would have put a minus here? Would it change the formula? Yes, and fortunately for us, all it does is changes that to a minus. So if you look on your formula sheet, you'll be able to find this formula, and it will have plus minus like this, and then I'll have plus minus there. Can I see it? I just want to make sure I'm not. Back. It's right there. They do them individually. Yep. The formula sheet actually doesn't do them together like this. They do the plus, and then they do a separate line, they do the minus. But a lot of books have these together in one line. It'll be plus minus, plus minus. So let's try and do something here. What is, as an example, what is sine of 75 degrees without a calculator? Well, what does this have to do with this, right? Well, here's what it has to do. This is actually 90 degrees. Crap, hold on. I did the wrong thing. Hold on. Yeah, we could do 30 plus 45, right? See, and the good thing about this is that you know something about 45 degrees and you know something about 30, don't you? Those are common angles. So according to this formula, this should become sine of what? This is alpha, this is beta. So sine of 45 times cosine of 30 plus sine of 30 times cosine of 45.
Not ever gonna do radians?
You could do radians. Yep. All right, what is sine of 45 degrees? What's the y coordinate at 45 degrees? Root 2 over 2. What is the x coordinate at 30 degrees? Root 3 over 2. Plus, what is the y coordinate at 30 degrees? A half. And then what is the x coordinate at 45 degrees? Root 2 over 2. Now let's multiply these two together. Let's multiply these two together. If I multiply these two, I go straight across. So I should get root 6 over 4, then plus root 2 over 4 again. So when you multiply roots together like this, you can just multiply the radicands. 2 times 3 is 6. And then here, 1 times root 2 is root 2. They have the same denominator, don't they? So root 6 plus root 2 over 4. Notice you cannot combine these together. All right, they're not like radicals. So that is our answer. This is the exact answer. Now, if you were to get that on your calculator, which I'll do real quick, I'm going to take root 6, and then I'm going to add root 2, and then I'm going to divide by 4. As a decimal, I get 0.96. Okay, get 0.96. If I had done on my calculator sine of 75 degrees, if I had cheated, I get 0.965. I get the same exact answer. All right? Yes? The root 6 and the root 2? Because they're not like radicals. So it's kind of like this. If I had root 3 plus root 3, that would turn into 2 root 3. It's 2 of them. All right? If I have 5 root 3 plus 3 root 3, this would become 8 root 3. This radicand has to match exactly in order for you to combine them together. It's like an apple plus an apple is 2 apples. But here you have an apple and an orange, and you can't put them together.
When you multiply, they can.
When you multiply, that's different. When you multiply, like when we did this, multiplication, you just multiply the radicands together. All right, so that is your formula. Let's do this. I'm wondering if you can't help me with this. Been working on this problem for a little while, trying to come up with the formula. Trying to come up with the formula for this. Is there a nice formula that I can use for that expression, sine of 2 theta? The argument of that expression is 2 theta, right? 2 theta. That's the argument, right? I have sine and I have 2 theta in here. I'm wondering if there's a way that I can write that so that my argument is not 2 theta, but my argument has theta in it instead of 2 theta. Well, we cannot pull the 2 out, right? You're not allowed to just factor 2 out of a trig function. That is way, way big time, like, that's like in the pits of math hell. They're just beating you for factoring 2's out of trig functions, right? You just can't. That's what I visualize. Like when I pull that out, I just vision some math with this whip. It's not factoring. It's a property. It's a property. It's not a factoring, though. So look, maybe we can use this formula. What's another way of writing 2 theta? Can I write it as addition? Isn't that theta plus theta? Isn't that the same thing? And then according to the formula, if I have sine of something plus something, right? Sine of something plus something, I'm supposed to take sine of the first one times cosine of the second one plus, right, sine of the second one times cosine of the first. So what would it be if they're the same thing? It would be sine of, let's follow the formula, sine of the first one, so theta, times cosine of theta plus cosine of theta times sine of theta. And wait a minute, aren't these exactly the same thing? So isn't it just 2 of those? 2 sine theta cosine theta. That's what sine of 2 theta is. And this is one that you should put into your memory. That comes up enough that you should know it. This is on your formula sheet. It's, I believe, called the double angle identity. This is a sum and difference formula, right? Here we go. We can use this formula to actually come up with the formula for sine of 2 theta. This only works for sine of 2 theta. If that's 3 theta, it doesn't work. It has to be 2 theta.
What about 4? Or like
Good question. Good question. What would happen if it's 4 theta? If it's sine of 4 theta, couldn't I still split that up into 2 theta plus 2 theta? And then I could do the same game I just did over here, and it would become sine 2 theta cosine 2 theta plus cosine 2 theta sine 2 theta, which would turn out to be 2 sine 2 theta cosine 2 theta. Right? So sine of 4 theta is 2 sine 2 theta cosine 2 theta. So it works for 4 theta.
you said it was a property, right?
This is a property, yes.
So, I mean, as long as it's even.
So what would it be if it was sine of 6 theta? If we're going to follow this pattern, what would sine of 6 theta become?
Sine 6 theta or
2 sine 3 theta
3.
cosine 3 theta. What's happening here is that we keep on, there's always going to be a 2 in front, but then we're always going to be cutting it in half and putting it here. Yes?
So it doesn't tell us that sine is equal to, or sine is 2 theta plus 2 theta.
If
You
it,
just made that
oh,
up.
this right here?
Yeah. Are you telling me that that's what it's going to give us, or we have to assume that? So we have to split sine of 4 theta in half.
You're going to have to split it. You're going to have to do this. If you want to use the formula, you're going to have to realize that it's this. But,
In a normal problem, it would just tell me sine 4 theta.
yes.
So I just split it in half.
Yes. Now, when you say in a normal problem, I'm talking about in calculus 2. Like in calculus 2, we'll get sine 4 theta, and then we'll just turn it into this, right?
So sine of 3 theta would be
So yeah, why not? Why doesn't sine of 3 theta work?
1.5.
I mean, if you try it, 3 theta, you could do this. You could do sine of 2 theta plus theta, couldn't you? I mean, that's right. But see, how does that change this line? This is the line that gets messed up. See, how does this line change? It's sine 2 theta cosine theta plus cosine 2 theta sine theta. That's sine of alpha cosine beta plus cosine beta sine alpha. No, sorry. I said it wrong. Sine alpha times cosine beta plus cosine alpha times sine beta. You can't put these two together because they're not identical anymore.
3 over 2.
So you could do a fraction. You could do fractions.
Would that help you after that?
What you basically wind up determining is this. If you ever have sine of 2 times some junk, okay? Junk. right? That this is equal to 2 sine of junk cosine of junk, all right? Whatever the junk might be. That's the main idea here behind this double angle identity. Oh, I'm out of time. Okay, do your homework for 8.3. I do not have homework solutions for 8.5 on video. So I haven't started. I have a very busy week. I'm going to try and get to it tomorrow. We'll see how it goes. But your homework is 8.3, not 8.5. So get that done. Come with questions. Let me turn off my camera. No, help you out. Hold on.